Welcome to Algebra 1. The learning goal for this episode is to learn how to multiply and divide rational expressions. If we let a, b, c, and d be polynomials, then a over b times c over d equals ac over bd, as long as both b and d are not equal to 0. Similarly, a over b divided by c over d is equal to a over b times d over c, simply taking the reciprocal of c over d, which then equals ad over bc. This time b, c, and d must not equal to 0. Let's look at an example to make that more clear. We want to multiply these two rational numbers. So we simply multiply the numerators together and then multiply the denominators together. That gives us 45x to the fifth in the numerator and 15x to the fifth in the denominator. Now we can reduce this fraction. 15 divides into both 45 and 15, and x to the fifth divides into both x to the fifth and x to the fifth. So we're simply left with 3 in the numerator and 1 in the denominator. Since 3 divided by 1 is 3, our simplified answer is 3. Our excluded value is 0. Since if x was equal to 0, then our original denominator would also be equal to 0, and dividing by 0 is not defined. Let's look at another example, again a product of two rational numbers. This time we're going to need to factor the numerators and the denominators to help us simplify. Now we divide out like factors. The quantity x plus 2, the quantity x minus 1, and x all divide out to equal 1, which leaves us with 2 times the quantity x plus 1 in the numerator and 5 times the quantity x minus 2 in the denominator. We could leave our answer like that, or we often go ahead and distribute if the only thing we have outside the parentheses is a constant like 2 or 5, and write our answer like this. Either way is okay. Our excluded values are 0, -2, 2, and 1, because each of those will make the denominator equal to 0. And again, we aren't allowed to divide by 0. Let's try another one. First, since it's division, we need to change it into multiplying by the reciprocal. Now we factor the numerators and the denominators. We now notice that we have y minus 2 in the numerator and 2 minus y in the denominator. So we factor out a -1 from one of them. I chose the 2 minus y in the denominator, but you could do it the other way, so that we have a common factor that we can eliminate. Now we divide out all of the common factors. If we pull the -1 out in front, that leaves us with this. This is in simplest form. Our excluded values on this one are a little tricky. We need to account for our original denominators before we take the reciprocal, and our new denominator in our divisor after we take the reciprocal. Therefore, our excluded values are 0, -2, 2, and -11. Don't forget the -11. That comes from factoring 4y plus 44 into 4 times the quantity y plus 11, which was in our original denominator, so it can't equal 0 either. Now for our guided practice section, we're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you with the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself, then I'll show you. So our first question is, what are we trying to do here? What we're trying to do is multiply these rational expressions, simplify them, and then state any excluded values that would make our denominator 0. How do we do that? First, we factor the numerators and the denominators. Now what? Now we divide out any common factors, including 3, which divides into both 3 and 9. That leaves us with b plus 5 in the numerator and 3b squared in the denominator. Now what? Now we need to state our excluded values. X cannot equal 0, 2, -7, or 1, as each of those would make our original denominator 0. Let's try another one. What do we do first? First, we need to change this division problem into multiplying by the reciprocal of the divisor. Since the quantity 2p plus 5 can be thought of as being over 1, the reciprocal will be 1 over the quantity 2p plus 5. Now what? Now we factor our numerators and denominators. What's next? Next, we divide out common factors. In this case, everything divides out. But we need to be careful because that does not mean this equals 0. When factors divide out, we are always left with 1. So in this case, we get 1 over 1, which divides out to be 1, which is our answer. Are we finished? No, we still need to state our excluded values. P cannot equal 3 halves or negative 5 halves, since either of those would make one of our factors in the denominator 0, which would then make us divide by 0, which is undefined. Now we're finished. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now, work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to multiply and divide rational expressions. We did that by learning to factor the numerator and denominator and then divide out common factors. If it was a quotient, we changed it into multiplying by the reciprocal, then factored and simplified. We continue to list our excluded values, and if it was a quotient, we know we also have to check the original denominator of the divisor.